Hello students, on this lecture, in this video, we're going to explore three more disaccharides, our final three disaccharides. We're going to look at these. All three of these have different glycosidic linkages. All of the disaccharides that we've looked at previously have 1,4 linkages, but these will have 1,6 linkages, 1,2, and 1,1. Let's look at these disaccharides. We're going to start with the 1,6 linkage. Okay, we're going to start here with our favorite carbohydrate, glucose. Up, down, up, down. And we'll go down with this one. This will be an alpha linkage. And so this is alpha D glucose. And then we're going to attach it to another glucose. CH2OH. That's up. This is down, up, down, and this one doesn't matter, so I'm going to put HOH here because it doesn't matter. And so the linkage here, let's number our carbons. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And so the linkage is going to be a 1,6 linkage. And so what's going to happen here? The electrons here, let's use red, the electrons here are going to attack the anomeric carbon. And our product is going to look like this. This is our first glucose, 1, 2, 3, 4, 5, 6. CH2OH. Down, up, down, and since this is an alpha linkage, this is going to go down here, O, CH2, that's going to be our 6. So, running out of space. Down, up, down, and this one does not matter. Made that bond too long. And so here we have an alpha 1,6 linkage. And so this disaccharide is named glucose, and then the linkage is alpha 1,6 glucose. That's the name of the disaccharide. Now we can use a shorthand for things. Of course, we can use a shorthand for things like glucose. So we could also call this, just put GLC, glucose, alpha 1,6 glucose. And you'll see that sometimes. Also, sometimes, instead of the comma there, just going to show you some alternate ways. Glucose, alpha 1, and then the arrow. There's an arrow going to the glucose. And we can, for any of our glycosides, for any of our disaccharides, we can write things that way. Now, this is somewhat redundant because all of the first carbons have to be anomeric, so they have to be 1s. And so, yes, they're all 1. Well, the anomeric carbon doesn't have to be 1, but for all of the disaccharides that we're drawing, if there's no number, it's understood that it's 1. And so we can also write it this way. We can call this glucose and then alpha 6 glucose. Okay, and that's this disaccharide. Now this disaccharide, remember, this end, well, here, this end here cannot open up. It cannot open up, and it can't reduce anything because it can't open. So this is the non-reducing end. So that's the non-reducing end. This end, however, because it has that anomeric carbon, it can open up to produce an aldehyde, and that aldehyde can reduce something else. It can take something's electron, something else's electron. So this is the reducing end. That is the reducing end. This compound, this disaccharide here, has a common name. It's called isomaltose. Because remember, maltose is alpha 1,4, and isomaltose is alpha 1,6. It's isomaltose. Now, you can have a polymer of isomaltoses. So the polymer, if you have a polymer of this, we call that polymer dextran. Dextran is the polymer, a very long polymer of isomaltose units or isomaltose disaccharides is called dextran. And this is our next disaccharide, and it has an alpha 1,6 linkage, and this is isomaltose. On this clip, we're going to look at our next disaccharide. However, on this disaccharide, we're going to draw the alcoholic disaccharide, the alcoholic sugar first. Okay, and that's going to be fructose. 2, 3, 4, 5, 6. We'll make this beta fructose, beta D, CH2OH, CH2OH. And this one goes down, and this one goes up. Now, in this next disaccharide, it's actually going to be the 2-hydroxyl, because if we number these, this is 1, 2, 3, 4, 5, 6. So it's the highlighted 2-hydroxyl. That's the one that's going to be the alcohol. That's going to serve as our alcohol for this glycosidic bond. And so what we need to do to this, so it means that fructose is flipped the wrong way. It needs to be flipped over. So let's flip it over. And this is not a simple task, flipping over fructose. So what I'm going to do here, I'm going to just grab all of this. I'm going to put all of this together. Okay, I'm going to move this over here. I'm going to make it a little smaller. Now I'm going to redraw fructose, but I'm going to flip it over. And so you just have to invert all of your ring substitutions. So this is going to be O, that's 2, make it 3, 4, 5, 2, 3, 4, 5. Okay, now let's number our carbon. So this is going to be 2, 3, 4, 5. Now I got to determine what goes up and what goes down. And so if we look over here, I'm going to highlight the 1 carbon here. Here's the 1 carbon. It's going down. So if I flip this over, it needs to come up now. So the 1 carbon needs to come up. CH2OH. There's the 1. There's the 1 carbon. And of course the hydroxyl now needs to go down. OH. And let's go on the other side here. I'm going to put the 6 and the H here. And so I'm going to highlight the 6 carbon. It's going up. So on the other side, that 6 carbon needs to go down here. So we need to have CH2OH. And I guess we'll do the hydrogen. We'll make the hydrogen like purple. It's down. So the hydrogen here needs to go up. Okay, now this is where things can trick you. Okay, I'm going to highlight the 4 yellow. The 4 hydroxyl is going down. So the 4 hydroxyl here on this side needs to go up. And I'm going to highlight this green. The 3 hydroxyl is going up. So here the 3 hydroxyl goes down. So these two, if you look at the bottom 2 carbons, 4, 3, 3, 4, they look the same when you're looking at it. That's why it's very easy for students to incorrectly draw fructose. So let's name this. This is alpha. Nope, this is not alpha. This is beta D fructose. And this compound is beta D fructose. However, this one is, the fructose is flipped over. And the reason I have you draw this way is because when you look at a textbook, almost always when fructose is involved in a disaccharide, it's always flipped over, almost always flipped over. And so let us make our disaccharide. And so the first molecule, the first sugar, the glycosyl or the glycoside portion is going to be glucose. So we'll make glucose blue. So 1, 2, 3, 4, 5. And then there's 6 CH2OH up, down, up, down. And on this one, I'm going to go ahead and make the bond. Go straight to the bond. It's going to be, the bond from glucose is going to be alpha. Okay, so I'm going to go down here. It's going to be an alpha 1, 2. So it's going to be, so here's my oxygen. Well, actually we lose that one. So let's get rid of this. It's going to be, I'm going to highlight it here. It's going to be this oxygen here. So let's put O. Okay. I don't know if I'm going to have enough room, so I'm going to have to lower all of this a little. So what I'm going to do, I'm going to bring this down here. O. Well, the O should be green. Come up. Now I'm going to draw fructose. Okay, and it's been flipped over already, so this is going to be easy now. CH2OH. Unless I've made a mistake, we're okay. CH2OH, OH, OH. Now here, I'm going to highlight the anomeric carbon. That is the anomeric carbon in glucose. This is the anomeric carbon in fructose. So now, let's name this. And the naming is a little different now because we have two anomeric carbons. So this is glucose. Now I'm going to, the one carbon of glucose is alpha, and it's connected to the 2 carbon of fructose, but I need to distinguish, is it alpha or beta? Since we flipped it over, this is now beta, even though it's going down when you look at it. It's beta because we flipped it over. So it's glucose 1 alpha, 2 beta, fructose. And that's the name of this disaccharide. And this disaccharide is the most common disaccharide in all the world. Well, for humans it is very common. This is table sugar. And the common name for this disaccharide is sucrose. And there we are, another disaccharide. I don't like to say about sucrose. You know what sucrose is. You know what table sugar is. Okay, there is something about sucrose that makes it biochemically very significant, very significant. And let's look at that. If we look at just fructose, you can see fructose has this anomeric carbon that can open up, form a ketone, and that ketone, just like an aldehyde, could possibly can do some sort of reduction. If we look here on glucose, glucose has, well, this can't open up now because it's attached. It's attached, so this can no longer open up. It can't form the aldehyde anymore. So that doesn't have reducing in, but it did. But in sucrose, if you notice, both of the anomeric carbons are involved in the glycosidic bond. So this anomeric carbon of glucose, I'm going to circle it here, of glucose can't open up. It can't reduce anything. And this anomeric carbon of fructose, it can't open up. It can't reduce anything. So if we look over here, the left end of glucose, of fructose rather, is non-reducing. It can't reduce anything. The right end of sucrose, this is highly unusual. The right end of sucrose is non-reducing because it can't reduce anything either. And so this will, in biochemistry, this will probably be the only sugar that you'll see that has no reducing end. And this is sucrose. So sucrose is said to be a non-reducing sugar. A non-reducing sugar. And I'm going to venture to say that in your studies, you will not come across another sugar that is non-reducing like sucrose. Maybe you won't. You won't. That's what I'm just going to leave it there. And so that makes sucrose very special. So sucrose is very special because it is, even though it's a very common sugar, it is uncommonly non-reducing. And not many sugars are like that. And so that's all. That's all that we have to say about this the most famous of sugars, sucrose. That we will look at will be another disaccharide of glucose. This disaccharide is very unusual. Normally you would never even see it. It's very uncommon disaccharide. And the linkage is alpha 1,1 linkage. So like sucrose, it is going to be a non-reducing sugar because there's no anomeric end to open up to form an aldehyde to reduce something else. And so you know what glucose looks like, so I'm just going to draw this compound here. I'm going to draw that we don't have to flip glucose over. this is up, down, up, down. Okay, there's alpha D glucose. Now I could flip it over. I don't know what's going to be. I'm gonna not flip it over because that's going to be easier for you, I think. So let's just draw another one. I'm going to draw another color so we can see it here. 1, 2, 3, 4, 5, 6. CH2OH. Up, down, up, down. And so here we have, this is going to be alpha D glucose, and this is going to be alpha D glucose. And so now I'm going to put the bond going down. And so this needs to go down. So if that one's going down, and I'm just going to draw the bond coming over here, put the O there, and this one is going down. Okay? And if you have two alpha bonds going down, and if I flip that over, it will be easier to see. This compound is called glucose. I'll just put GLC, glucose. Now this time you're going to have to put one alpha and then one alpha glucose. Okay. If I drew that, let's go ahead and draw it. Let's flip the other glucose over. This is the tough part. So let's flip this over. I'm flipping this glucose over here. I'm going to number the carbons. 1, 2, 3, 4, 5, 6. So it's going to be 1, 2, 3, 4, 5. Now the thing is, if we flip this over, 6 has to go down now. And so this is what makes this tough. CH2OH. So that has to go down. 4 has to go up because it's down. 3 is up, so 3 here has to come down. 2 is down, so 2 has to go up. And now, if we want this to be alpha, alpha is going down here, so alpha has to come up here. And so, well, I'm going to erase this. I'm going to draw, it's going to be a much easier way to draw this. I'm spending much more time on this one than I wanted to. So I'm going to group that and bring it down a little. And so since this one has to be alpha, so hope this is not confusing. So I'm going to still make this one black. So this has to go this way, because over here, if it's going to be alpha, it's going to be going this way. And so this is going to be O. And so this is alpha D glucose. And now this one is going to form. And this is going to be the regular glucose. Well, there's nothing regular about that. Up, down, up, down. And so this is alpha D glucose. And so this compound here is glucose, 1 alpha, 1 alpha glucose. Now this compound has become more important lately. It's called trehalose. Trehalose is the name of this compound. And this compound, it really prevents it protects insects from certain conditions. It protects them from dehydration, because it's found in their lymph, or in their blood, which is called hemolymph. It protects them from dehydration. It protects them from cold. It's a cryoprotectant. It protects them from high salt concentrations and from high temperatures and from heat. And they used to think, it was first thought that this the trehalose, because it's something like sucrose, is a polyhydroxy compound. It works like an antifreeze, but that's really not how it works. It actually works through it's a signaling molecule. It signals the cells to produce protective proteins like heat shock proteins. So it's a signaling mechanism. And that's what trehalose does. I was just looking. I was looking on the internet about trehalose, and I saw that there's a paper out about trehalose, and it says that trehalose may be involved in the treatment of Huntington's disease. I don't know. Huntington's. I think it's Dunn's. Huntington's disease. I haven't explored that a lot, so I don't know how credible that is. But you can see this compound trehalose. Scientists have started to discover that this trehalose does many, many things. And so this is trehalose, an alpha 1,1-linked glucose disaccharide. And that concludes all of our disaccharides. And we've looked at various 1,4-linked disaccharides. We looked at a 1,6 disaccharide, isomaltose, a 1,2 fructose, which is non-reducing, and a 1,6 and a 1,1, which is trehalose. And it is non-reducing, because this end of trehalose is non-reducing. I'll just put non-red, and this end, or the opposite end, would be non-reducing. It's hard to see it here because you don't have a left and a right. They're both on the left. But if you look here, this is non-reducing. The anomeric carbon is not over here. So this is non-reducing, and this is non-reducing. So trehalose, just like sucrose, is a non-reducing sugar. And that ends our disaccharides. Hope you understand it.